Today we start into your last chapter, chapter 12, which deals with three-dimensional figures, specifically looking at your pyramids and your prisms, your cones. Hold on one sec. Jack, I'm recording. Sorry about that, my son was coming downstairs. Anyway, it says identify the base of the figure below. So when we look at that pyramid that we have there, to identify the base, what we are looking at is this shape here on the bottom. So that shape has, if we count, 6 sides. So that 6-sided shape is known as a hexagon. So the base of our pyramid was a hexagon. Alright, introducing the idea of your solids. A polyhedron is just a solid, meaning it's a three-dimensional figure that's bounded by all polygons. Specifically, we're going to look at 2 of them throughout the chapter. We're going to look at your prisms and your pyramids. To be a polyhedron, all faces must be, as they call them, polygons. That face, it's what essentially some people like to call a side. But there's some confusion when you use that word side, whether you're talking about that crease or whether you're talking about one of the polygons that make up that polyhedron. So we determined a face is each of those polygons. So in your opener, your faces were all of the triangles coming around the side, and then that hexagon on the bottom. Those were all of your faces that we're going to talk about. So your faces are the polygons that enclose the solid part of your polyhedron. Where 2 faces meet, they call that an edge. It's the line segment formed by the 2 faces of a polygon, or I'm sorry, of a polyhedron. So when you go back up to the opener again, a edge is where 2 of your faces meet. So if I take 2 triangles, for example, that come around, this line segment that they create right here, when they touch, that is known as an edge. Last part then, or last piece there, instead of dealing with an edge, when 2 edges meet, they create a vertex. A point where 3 or more edges meet. So it's each of these, it is each of these points, here, 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 back here. These are all vertices, where 3 or more edges intersect. Now, as far as those as far as the polyhedrons go, your bases are at the ends of your polyhedron. In a prism, they are essentially going to be the 2 non-rectangles. They are going to be 2 polygons that are all joined by rectangles. In a pyramid, you are going to have triangles that join it. There's my triangle on the bottom. Then I have all these triangles coming around. Those 3 all join that bottom part to that top vertex. So here, the base of your pyramid is this triangle that's down there. So let's take a look at the 3 examples here. First, it says tell whether the solid is a polyhedron. To be a polyhedron, as a quick reminder, it must be made up of all polygons. So in A, first question, is it a polyhedron? It's made up of all rectangles, so it's yes. In B, we have the hexagon on the bottom, the rest is all triangles, so it's yes. When I look at C, C has that circular part to it. This is not a polyhedron. It is not made up of all polygons. So for the A and B then, we have other questions to answer. It says, if it is, name the polyhedron. So first thing about naming a polyhedron, you have to identify, is it a prism or is it a pyramid? So in A, it is a prism. In B, it is a pyramid. Now, they do have a more specific name to them. When you name a polyhedron, not only do you have to identify whether it's a prism or pyramid, you also have to identify the base. So, B is the easier one, because we talked about it in the opener. The base here is this 6-sided figure on the bottom. So, since a 6-sided figure is called a hexagon, we call this a hexagonal pyramid. As for your prism must be joined by all rectangles. Well, in this case, you actually would have options, but typically since the markings are there, we talk about it being in the front and the back, and it is a rectangular prism. Now, third part then wants you to identify the number of faces, vertices, and edges. So, faces. How many polygons are there in A? I got the front and back rectangles, the left and right rectangles, top and bottom rectangles. So there are 6 faces. As for my vertices then, I have the 4 in the back, 1, 2, 3, 4, and the 4 in the front. Counting up my vertices then, there are 8. As far as my edges go, we have the 4 in the front for my rectangle there, the 4 in the back, and then the 4 that come down and join them. 1, 2, 3, and then this one that was down here. 4. Oops. So there were 4 in the front, 4 in the back, and then the 4 that joined them. So I have 12 edges. In in B, counting up my faces, there are the 6 triangles that go around and the 1 hexagon on the bottom. So there are 7 faces. For my vertices, there are the 6 vertices on the bottom. 1, 2, 3, 4, 5, 6, and then 1 up top. So there are 7 vertices. And you will see in a pyramid, those 2 items are always the same. And then finally, they want your edges then. I have the 6 that go around for the bottom hexagon, and then I have the 6 that come. I have the 6 that come up and join them to the top. So there are 12 edges. Now, a regular polyhedron is a polyhedron that has faces that are all regular. And well, looks like I might have to break this into multiple videos. So please stay tuned for video 2.